How do I adjust the network settings? Smart Drainage is designed to be flexible and adapts to the user's CAD standard or drawing structure through the network settings form. This lets us control which graphics Smart Drainage will interpret as nodes, links, and catchment boundaries, and how the nodes and links are named. These settings are stored separately for each network, and also update the default settings that will be applied to any new network that is created. Smart Drainage maintains separate defaults for storm and foul networks. We start with node definition. All flow nodes created by Smart Drainage during network discovery will have numeric names. However, it is worth knowing that Smart Drainage will keep unchanged any non-numeric names that it imports from Flow. We will now look at what each box represents and how you can make adjustments to it. First node number sets both the value and the format of the numeric names. Leading zeros may be entered if a minimum length of name is required. For a new network, the first node number will apply to the outfall node, incrementing in the order of discovery. For existing networks, the value of any new node numbers will increment from the greatest numeric value already in the network. Nodes in Smart Drainage may be represented by either circles or block references. The center of a circle or the insertion point of a block is used as its node coordinate. When defining a node block, it is important to set its insertion point at a meaningful position relative to its graphic entities. Wildcard mask for node layers tells Smart Drainage to apply a filter to the names of the layers on which it will search for the node entities. Your masks can include the wildcard characters star, which matches any number of characters including none, and question mark, which matches exactly one character. Most CAD standards can yield a tighter definition than the default star, which includes all layer names. In this example, we have put the foul manholes on a layer called foul node, and the storm nodes on a layer called storm node. If we set the node's layer mask to star storm star for the storm network, then the foul manholes will be ignored. For simple layouts, it is possible to put nodes, links, and catchments on the same layer and leave the mask as star. Smart Drainage will still be able to identify and build the network for you. Wildcard mask for node blocks tells Smart Drainage to apply a filter to the names of the blocks it will consider as nodes. Where the CAD structure is suitable for masking, some errors may be avoided by a mask that is better defined than the default star, which includes all block names. For example, if the only blocks used for nodes are mh_a and mh_b, then a mask of mh_star would ensure that other blocks are ignored. Moving to link definition, the format of link names created by Smart Drainage during network discovery may be either the traditional dendritic run number plus sequence number, such as 4.012, or it can use their upstream node name. Ticking name links from upstream nodes will use the second method, which is more resilient to changes in the layout during the development of the design. For Flow Plus networks, Smart Drainage adds alphabetic suffixes to multiple outlet links from the same node to achieve uniqueness. For example, 002A and 002B. Link to node tolerance sets the maximum distance from a node coordinate to the start or end point of a link graphic for Smart Drainage to consider them as connected. A link will be connected only to the nearest node at each end, even if more than one is within the tolerance. Smart Drainage calculates the link lengths between the center points of the nodes at each end, or more precisely, between the normals from the node points at each end. But the links may be drawn to the edge of the nodes if preferred. The tolerance must allow for the largest gap that will be encountered. The network discovery process highlights the nodes and links, which should identify any problems. To represent links, Smart Drainage accepts line, arc, or polyline entities. Line is a logical choice where the link is a straight pipe. Arc adds support for legacy non-straight pipes that are drawn as single arcs. Arc entities will be converted to equivalent polylines whenever Smart Drainage needs to set their direction to be clockwise. Polylines are the most versatile entity to describe the planned route of links, especially those that are not straight, such as ditches or those following the alignment of roads. It is the user's responsibility to ensure that the chosen pipes can be laid to the curvatures or bend angles drawn. Blind or curve-fitted polylines are not currently supported. Wildcard mask for link layers tells Smart Drainage to apply a filter to the names of the layers on which it will search for links. Set this to fit with your CAD standard. Separate layers for storm and foul make the layout more comprehensible. Wildcard mask for link line types tells Smart Drainage to apply a filter to the AutoCAD line types that the link entities are drawn with. Some CAD standards may require specific types for drainage. Unless all the line types can be described with a mask, this should be left as star. Next, for storm networks only, we have catchment definition. We have reconfigured the drawing to demonstrate the options that are available. As an alternative to entering impermeable areas in flow, Smart Drainage can measure the area of polyline boundaries that represent the catchment areas and assign them to the nodes. Impermeability factors can be coded in the layer names, and the impermeable area for a single node may be calculated from multiple catchment boundaries. Smart Drainage supports the very versatile capabilities of Flow to assign catchment both to nodes and as lateral inflow directly to links. Either or both methods can be used in the same network. The two wildcard masks for node inflow catchment layers and lateral inflow catchment layers let Smart Drainage know where to apply a catchment. If either mask is blank, that mode will not be used in the network. If both are used, Smart Drainage will check all the layers in the drawing to make sure that no layer names match both masks. If that happens, Smart Drainage gives a warning and will not process the network until it is fixed. Impermeability option name is a mechanism to allow users to specify areas with different impermeabilities by creating layers for each value required. The option name is a part of the layer name that comes immediately before the numeric value of the impermeability to be applied. The value may be a decimal or a percentage. For example, where wildcard mask for catchment layers is catchment star and the impermeable option name is _imp, the layer name catchment _imp 0.7 or catchment _imp 70 would both mean an impermeability of 70% should be applied to the areas of any polylines on these layers. Catchment to node link midpoint tolerance is a distance that is used in assigning catchments to nodes or links. We will describe how it works with some examples. All catchment boundaries must be drawn as polyline entities on layers that match one of the wildcard masks just described. To accommodate varied user preferences, Smart Drainage can handle several options. The catchment boundaries may be closed or slightly open by not more than the link to node tolerance. Closed boundaries for node inflow will apply to the node that is inside the boundary, and if there is more than one, the one nearest to its centroid. If there are no nodes inside the boundary, Smart Drainage will search for the node that is closest to the boundary. If its distance from the boundary is within the catchment to node or link midpoint tolerance, then it is assigned the catchment. Open boundaries for node inflow will apply to the node that is nearest to the start point of the boundary, if the distance from the node to the start point is within that tolerance. For lateral inflow, there may be more than one link to be considered. In Flow+ networks, there could even be more than one link on the same line, for example, a slot drain above a carrier drain. You can control which links carry the upstream flow and which receive lateral inflow by adjusting the order of the link types in Flow's Libraries section. Closed pipes and culverts should be at the top of the list, then the porous pipes, and lastly the open channels. Closed boundaries for lateral inflow will apply to the link with its midpoint inside the boundary. Where there is more than one, it will be the link whose link type is lowest down the list. And where there is more than one of the same link type, the one with the midpoint closest to the centroid of the catchment. If there are no links with a midpoint in the boundary, then Smart Drainage finds the closest link midpoint outside the boundary. If the distance is within the tolerance, then the catchment is applied to that link. Open boundaries for lateral inflow apply to the link with its midpoint within the distance tolerance to the start point of the boundary. If there is more than one, Smart Drainage applies the catchment to the one with the link type lowest down the list. Where areas have been assigned in Flow and then imported to Smart Drainage, or where the imported areas do not match those found by Smart Drainage, adjustment areas will appear as pinhead symbols. These may be replaced with more accurate boundaries using standard CAD methods. Default catchment impermeability is the value to be applied on any catchment polyline drawn on a layer that does not include the impermeability option name. The 3D settings fix how Smart Drainage reads or writes level information from the node or link entities. If a smart surface has been assigned to a network, Smart Drainage always uses it to get the cover levels of nodes and the invert levels of links. But where there is no smart surface, the 3D settings use cover levels from node entities and use invert levels from link entities, control whether the Z values of the graphic entities are used to supply levels to Flow. The last of the 3D settings, Update CAD entity levels from Flow, controls whether the Z values of the graphics are updated when the Flow file is imported back into AutoCAD. If this is selected, all the node graphics will be set to cover level, and all the link graphics will be replaced by 3D polyline entities with a constant gradient from their upstream to downstream invert levels. For the remaining annotation settings, please refer to the video How do I define my annotation settings? Now that we have orientated ourselves on network settings, let us click the OK button to save the settings. The other option of cancel or close with the X would discard any changes.